Welcome back to the second video for Unit 3, Atomic Structure and History. Today we are taking a look at Rutherford's gold foil experiment. So what do you think happens when particles pass through gold foil? So let's back up for a second. At the start of the 1900s, Dalton thought atoms were just solid spheres, and Thomson thought they were pudding with electrons inside. But Rutherford wanted to test these ideas. His gold foil experiment would completely change how we actually see the atom entire. So let's take a look at his setup. So I'm talking through, but I have this video playing so you can kind of see an animated version of the diagram on the right. So his team actually fired tiny positively charged particles called alpha particles at a very thin sheet of gold foil. Around this foil was a screen that lit up whenever a particle hit it. Based on Dalton and Thomson's model, the team expected every particle to pass straight through with no surprises. But we can see that's really not the case. So as these alpha particles are shooting through the setup, we can see that we have that nucleus in here, though at the time they didn't really know that it was there. So they're expecting it to pass straight through. Instead, occasionally it's actually bouncing off of this nucleus and either getting deflected off to the side, or in some cases, if it's a direct hit, coming straight back where it came from. So let's look at our results. So the prediction again was that all alpha particles would pass through the atoms in the gold foil in a straight line. And they expected like a very small fanned out location to show the hits. But in reality, some alpha particles rebounded in those unexpected ways. Again, most went straight, but a few were redirected off to the side. And what really shocked them was the ones that came straight back at them. So again, that left side is kind of what we expected to happen. The right-hand side actually shows what really did start happening with it. So whenever he actually finished this experiment, Rutherford was shocked. He said it was like firing a cannonball at a tissue paper and having it bounce back at you. It was extremely unexpected. So our conclusions from this experiment was that atoms are mostly made up of empty space, but they also have a tiny, dense, positively charged center that cause the particles to bounce away. This center is what we call the nucleus. Now, it didn't completely answer all of the questions. There was a few shortcomings, such as we still didn't know that a neutron existed. So there was still that large issue of worrying about the moles collapsing in on themselves following the laws of that classical electrical dynamics. And on the other hand, and we haven't gotten to this quite yet, but as those electrons are moving around in their paths, we expect to see a full spectrum result coming off of them. But instead, we're only seeing bits and pieces. So that'll make a little bit more sense later on. Let's add this to what we already know. We had our Billiard-Bell model to start with. We increase it, we realize that we have different charges happening with the plum pudding model. And now we finally know that we have a positive nucleus. Up next, we're going to take a look at Bohr's planetary model.